Hey everyone, how are you doing? Today I wanted to show you the latest project I've worked on, which is a PWM drawer, which basically operates as a mini oscilloscope, but only for digital signals, not analog signals. But anyways, I've used the Atmega32 microcontroller along with a graphical LCD to output the waveform and the data of the signal. I've also used this button to freeze the screen, and this LED to indicate whether we're currently actively reading a signal or the screen is frozen. Also notice that here from timer 0 I have the PWM from timer 0 and keep on dynamically changing the duty cycle from this PWM, and here that's the signal that we're going to read straight into the input capture unit of timer 1. So basically I'm reading the signal internally. There's no external source of the signal. It's being generated by the Atmega32 and currently being read by the Atmega32. So let me show you how this works. See here, as you can see, duty cycle keeps on updating and the waveform keeps on updating as well as the duty cycle changes. Of course, the frequency and the periodic time, they're not going to change. Notice here that per frequency of near 1 kilohertz, the periodic time is 1 millisecond. Of course, you'll notice that the accuracy here, it's only 1 decimal. So this should be 1.02, but here, since the accuracy is 1 decimal, it just reads as 1 millisecond. Okay, so if we press this button to freeze the screen, as you can see, it doesn't change and the LED is turned off, and as soon as I turn it back on, you'll see that it has jumped because it has been updating all this time. We just haven't been reading it. Okay, so let me try with an external source for the signal now with the signal generator. So let me just connect this to ground, and let's call this signal 1. Let's take signal 1 instead of the internal signal. Let's turn this on. Of course, doesn't change yet because we haven't really used the signal generator. Okay, so here let's change it to an analog or a digital signal. Let's adjust the level to 5 volts because that's what the Atmega operates on, and let's here update the frequency, and as you can see, keeps on updating dynamically. As we change the frequency, it keeps on changing here the readings and the waveform. Of course, here we've hit the limit of what we can read with the Atmega32, because of course we're limited by the Atmega's own internal 16 megahertz clock, and I've also used a prescaler of 64 if I remember correctly. So we're limited by that number as to what signal or like the frequency of the signals that we can read. Anyway, so here's the project. You can find it on GitHub. You will see the link in the description in case you want to check out the source code or this simulation file or everything you want to check out about this project. And hope you've enjoyed it, and see you soon.